Welcome to all our attendees. I'm delighted to welcome you to the fourth webinar of our 2025 series. My name is Satwinder Paul, and I teach in the Water and Wastewater Technology program. Alongside a team of experts and co-creators, I oversee the Online Help Center for BC Small Water System. Before we begin, I'd like to acknowledge that Thompson River University campuses are located on the traditional lands of Tecumlip Swetmec and Texelic, within the Swetmec Ulu, the traditional and unceded territory of the Swetmec. Thompson River University and their partners host an annual free webinar series and courses designed to provide technical information, resources, and tools to all small water system owners and operators, including Indigenous small water systems. These webinars, courses, and the website cover topics on treatment, regulations, operations, maintenance, and water quality monitoring. The Online Help Center is committed to assisting small water systems across BC in implementing a multivariate approach to drinking water, ensuring safe, potable drinking water for their communities in compliance with government regulation. Our free webinars are scheduled every 2 months in 2025, and they are worth EOCP CEUs of 0.1 CEU per webinar. Okay. After your participation, you will be automatically given a certificate online, which you can then submit to EOCP for your CEUs. We also have an exciting update. We are offering 2 additional free courses that can be done online. So please check them out on our website. The courses deal with emergency response and contingency planning for small water system, and an EOCP exam preparation for small water systems. And there are more courses coming forward in the next few months. Today, our webinar is on utility resilience and reliability, source to tap. The webinar covers running a reliable and resilient water system requires continuous adaptation. This webinar will explore key characteristics such as environmental factors, process maintenance, and stakeholder relationships, all from an operator perspective. And our speaker today is Nick Olson. Nick Olson is a Campbell River Water Department employee and a graduate of Thompson River University. He holds certification in water treatment level 1 and water distribution level 3. His experience spans fire protection, pulp mill operations, pipe fitting, and water processes. So welcome, Nick, and we are looking forward to your presentation. So we will have 1 hour of presentation, followed by a half an hour for questions. So Nick, I turn it over to you.
Great, thanks very much, Satwinder, for the introduction. And hi and welcome everybody to today's presentation. As Satwinder said, my name is Nick Olson. I work for the City of Campbell River Water Department. So this isn't really a how-to, but rather it's going to be a discussion about practices, best practices, and ideas about utility resilience and reliability, and some of the ideas that we're doing up in Campbell River. So I hope you enjoy it, and if anything, I hope it sparks interesting conversation and questions as well. If you guys see something and you want to make note of it in the question period, things that are working for you or aren't working for you, I'd love to hear about it. So with that, we'll just jump right into it. So the talking points for today, we're going to be talking about defining our mandate, stakeholders, those are relationships, critical infrastructure, environmental considerations, vulnerabilities and redundancies, the wildfire interface, which is a hot topic, of course, Campbell River's water system, discussion points, basically around preventative maintenance. And then we'll touch on AI and digital threats to utilities. So the picture here, that's John Hart Lake. To the right is the clean water that we draw upon into Campbell River. And to the left, this is a dam project that's happening that BC Hydro is doing. They're doing an upgrade. It's going to take about 6 or 7 years. And the reason I included it is because that berm is the only thing that's separating their work site and all that turbidity and nastiness that's being dredged up, and it's being separated by this berm. So they have a plan in place if there was a breach, and then they would let us know. We would activate our plan, but they're doing a really good job. They're monitoring it constantly, and we haven't had really any issues yet. Okay, so defining our mission. Of course, we're following the BC Drinking Water Protection Act, and the Drinking Water Protection Regulation is our foundation. And our mission is simply put, is to provide water that is suitable for consumption and for fighting fire. And to achieve this, we kind of have a layered approach. We have operational competence, preventative maintenance, kind of tied in with asset management, and then capital investment and stakeholder relationships. This picture here is in the downtown core, our lowest zone. And what's going on here is we've increased the pressure downtown, and we'll talk about that a little bit more later, but there's a good reason for it. But it's proving out a lot of the old infrastructure has a lot of weak points in it, and a lot of things were kind of just on the edge, and a few of these things have been pushed over the edge. So a cork popped out of the main here, and there's a big spiral fracture in the cast iron. So we dug it up. It was quite a day, and it was business as usual. Okay, so essential service. Resiliency, it means to withstand or recover quickly from emergency conditions. That's kind of the theme of today. And essential utilities are expected and they're counted on to perform their duties under any and all circumstances. So we achieve this by running reliable systems for our customers. And here's a picture. We're doing a small capital upgrade. We regularly are getting rid of old PRVs, and we're in a chamber here. And we had some stubborn bolts that wasn't coming off with the socket set, so we decided to cut them off. And I will point out that this operator, he's wearing a hoodie with strings, which isn't appropriate for running a grinder. It could get caught up, so he shouldn't be wearing that. And on top of that, he should actually be wearing a face mask, or even just like a full face. We wear that now because you get the particulate protection, but also your face is fully covered and protected. And I don't mind saying that because I know that guy. That's me, so I don't mind calling myself out. Okay, so stakeholders, they're stronger together. And the definition is people and entities that affect outcomes related to our mission. As I like to say, friends in high places from different spaces. It's kind of cheesy, but it's true. So I have a bunch listed, and there's even more, but I'll just highlight and talk about a couple. So ultimately, the taxpayer, they're our customers, and we serve them. So like I was saying, they expect that the utilities are going to run and function no matter what. People want to wake up to flushing toilets, and they want to wake up to their water running in all conditions. Different levels of government. So policymaking and funding power, grants for infrastructure projects. This is kind of at the higher level of management and the echelons of decision making, but it doesn't mean that we can't be in on the conversations when we're in operations or safety meetings. We know the system better than anybody, so we should be bringing forward our concerns and kind of having like a lobbyist outlook. We want to make sure that we're befriending the right people and influencing them so we can get positive outcomes for ourselves and our utilities. In Campbell River, BC Parks, they have a bunch of trees that are really close to our water supply center. That's our intake building. And they're in the way because we're putting in some new reservoirs. So we want to have a good relationship with them and try and streamline this process as fast as we can, so we can get those trees out of the way. Indigenous nations, they're also customers, and they're also growing political players. And fire service, we provide reliable, sustained water for them so they can do their jobs, and we do maintenance on their hydrants. and in return, they give us public safety. And then I have industry experts, and they influence policy, and those are people like that sit on the boards, right? People that sit on the EOCP board or the BCWWA, that sort of thing. So critical infrastructure, source water. Is there a source water protection plan? Is it working? Are we compiling data and trending it? Power supply, this will come up later, but we have primary and we have secondary power supply. We want to make sure that our backup supplies can perform under prolonged heavy demand. It's not enough that they can just be turned on and run under a light load. They need to be able to handle a full load, and it needs to be able to be sustained. Communications, so radio and fiber, is it reliable? I'm not talking about walkie-talkies. I'm talking about like your communications for SCADA and how your system is communicating with PLCs and controllers and things like that. So to go with that is the SCADA systems. Do we have technicians that are ready and available? This is really specialized stuff. So we need to have these people familiar with our system, but they also have to be available. And when they go away, we need to make sure that someone's filling their role. Chemical, material supply, and logistics. So are there multiple routes? Are there multiple sources? So I'm talking about things like your chlorine or your hypochlorite, your coagulants, that kind of stuff. For us, it's salt. We make our own bleach on site, so we have to have ample salt, and we keep a lot on site. Distribution systems, so your piping, your reservoirs, our capital upgrades, are they funded and are they being completed in a timely manner? We have some water mains that are getting pretty tired and they keep breaking over and over. So that triggers a response where that gets put at the head of the line for a capital upgrade. Okay, so here's a better picture of that dam project and our intake. So our intake's just to the left of the first berm here. So that's why it's really important for us to be constantly keeping an eye on this thing and hydro as well. And they actually have like a 4-inch pump that's pulling out of this consistently. And the idea is that if that berm has a small breach, fresh water will be pulled in, and then instead of that water exiting out into the lake itself. So it's one of the measures that they're doing. Okay, so we'll quickly talk about the threats to water infrastructure. So the obvious one is wildfire interface, landslides and disruption to logistical supply lines, cyber attacks on digital infrastructure, lack of planning, collaboration between stakeholders, inadequate resources, funding and training, lack of control over policy. What I mean by that is that most utilities belong to a municipality, and we're just a cog in the bigger wheel. We're not necessarily just the focus on long-term planning and funding and things like that. So that could be a challenge, right? We want to do a lot of stuff. We want lots of money and we want to do lots of upgrades, but they have to think about some of the other things that they have to look after, some of the other departments. Single source, single intake. It's kind of a wish list item for me. Some places have it. We don't have it, but I think it's cool that if you had a problem with your intake that you could switch to another one. Aging infrastructure, that's something that we're all facing. It'd be interesting to see how it kind of unfolds in the coming years. It might be the federal government may have to step in and provide some funding for this stuff, because I think that we're just really behind as a country as a whole. And this is a picture here of the Donnie Creek wildfire, and it just shows the magnitude and how much pollution is going into the air and just how big these things really are. Okay, so I'm just going to touch on source water. So the Campbell River Water Supply Center, like most plants, we were monitoring the raw water coming in, so the conductivity, pH, temperature, turbidity, UVT, like the clarity for the UV lamps. And on top of that, regular organized sampling. It's a regime that gives us data on pre-treated water characteristics. So changes in the ecosystem can be potentially detected. And then long-term data can be trended properly, and we can use that to tell what's going on out there on the lake. And then in the short term, maybe we can detect events such as the algae blooms or turbidity runoff from different events that might take place. So that stuff's found in the Part 5 of the Drinking Water Protection Act. There's a lot to it. If you're interested in that, you can check it out there. And this is just a picture of us out parasite sampling. We're using the FilterMax filter from Hyperion Labs, and that comes from Medicine Hat. Okay, so here's one of the other threats, the logistical vulnerabilities. So everybody probably remembers the atmospheric river back in 2021. Everyone's like, what's an atmospheric river? Wow, it's this heavy rain, and it got this cool name. But the flooding in the washouts damaged more than 20 sites along the Coquihalla Highway, 130 kilometers. And 7 bridges were completely collapsed or heavily damaged. So the reason I throw it in there is that I was talking about different routes for our supplies for our plants, and this stuff is not traveling on this highway at this point in time. And luckily we have other highways, but you can just imagine that something this bad happened to this highway, and then maybe just 1 or 2 other events happened at some of the other highways. We have major backlogs. So if you're looking for something material-wise that you need right away for your process, you might not get it. So that's why we want to think about this, these routes and the availability of products from different suppliers. And that's why I bring up stockpiles. So like I was saying earlier, we have hypochlorite that we generate on site. And to do that, we use salt. So on the floor there, you can see we have about 14 pallets of salt ready to go. And this time of year, with the heavy flows, we're using about a pallet, almost a day, a week, roughly. So once we get down to maybe 7 pallets, we're going to think about ordering another set and keep that stockpile way up. So bridge or no bridge, we're making bleach. That's the idea. So with that, we don't want to be a one-trick pony either. So taking systems offline for maintenance or emergency repair, it's going to happen. So we need to plan for it and expect it. Taking reasonable steps to imagine outcomes as they might unfold in undesirable situations. That's kind of what I'm getting at. And then when you do that, you can let this determine your system's vulnerabilities and your state of readiness. So storage capacity and redundancy are key. And right here, we're looking at our 2 hypo tanks. That's where we store all of our hypo. And then to the left, there's our main dosing skid, and it's pumping the bleach into the system. So also in this picture, we're actually taking these offline one at a time, and we're cleaning them out for their, I think every 3 years, we give them a clean out. So the redundancy piece for dosing for a critical system like this would be having a separate system altogether. So we have 2 to 4 barrels of 12% bleach, and we have these Grumphos pumps, and we can switch that system off, isolate it, and we can pump bleach in from this system. And this is our redundancy. So if we need to do emergency repairs over there for whatever reason, we'll switch to this and we'll run this. And it's good to run through it if you do stockpile it and you have it as a backup system. You want to run through it probably every 3 months or so because it starts to degrade and loses its potency. And then the second part to that is you can get your operators to practice switching in between the systems because it's not seamless. And if you've never done it before, it's a little bit nerve-wracking. So in Campbell River, we have an on-call system where all the operators go on call for a week at a time. And they're distribution operators and they do some of the treatment as well, but they have to look after both when they're on call. So this is a good opportunity to get them up there and practice switching in between systems. Okay, so this is why. So this is the main dosing skid. And as you can see, we have 2 pumps and only one runs at a time. So there's a bit of a redundancy there, because if one craps out, you can run the other one and then fix the one that crapped out. But the problem is they share a common header on the bottom there. That's drying off the tanks. So what happened here, these are displacement pumps. That bracket on the bottom left, it wore through the line and created a leak, and it was obviously going to get worse. So we tackled it by isolating this system completely, isolating the tanks, switching on that emergency backup system, 12%. And at this time of year, with the amount of bleach we had on site, it's about 16 hours of dosing available. So we cut that piece out, and we just glued in a straight piece there, and we used 2 unions, so we didn't have to push apart the brackets and take a bunch of stuff apart. It was just put it in and do it up, and you're good to go. And off to the races we went. Everything held, and it was good. And we switched it back on. So in a similar case, this thing's getting, it's not old, but it's about 8 years old. So we're starting to get some things leaking now. And here, here's a case where we're able to just isolate the one pump that was leaking and then turn on the other pump, like how it was designed to be. But as you see that it's pretty tight, and there's a bit of orientation involved. So if you're gonna tackle something like this, or if someone asks you to, after you isolate it, you take it apart. Before you take it apart, you should take some pictures and really study the orientation. As you can see, there's a back pressure valve in the back, where the handle's in the back of this pressure gauge. You have to get that right, obviously, the first time. Otherwise, you're gonna have to cut it apart and redo it. And the same thing with the unions. Make sure you get your collars in the right place before you glue them, because you'll go to do it and you'll notice your collar's not on, and then you're cutting it all out again. And that's why I said it was a little tight and there's a little more swearing, because these things happen. So in the bottom right picture, I just wanted to emphasize that if you're going to be doing some gluing on systems that are corrosive, like hypochlorite, make sure you use the right glue. That orange can is specifically for things like hypochlorite. It's listed on the can there. And then additionally, you want to make sure that you have spare parts available to you and stocked and cataloged. We don't want to be having these situations come up where we need to make repairs, and then we have to worry about securing supplies. You should have some backup supplies on hand and ready to rock and roll. Okay, so like I was saying earlier, we have an on-site generator, and it's pretty sweet. It's all I've ever known. Before this, we did have chlorine gas, but when this plant was built, they pitched the gas and they installed this system. And it's pretty slick. The only byproduct that's dangerous is hydrogen gas, which is a very explosive. But there's a bunch of interlocks built into the system, and there's blowers, and they had to be running and ejecting before this thing even starts up. So it's quite safe. We have hydrogen detectors all around and lots of fail safes. So it's a good system. So here we're doing maintenance on it. This is a scheduled muriatic acid wash, and it takes off all the stuff that gets baked onto the plates inside, and you'll start to notice it kind of running funny, and your testing will be a little bit off. But we kind of go by hours as well. So like every 1,000 hours, we'll start to think about running an acid wash on this thing. And you can use vinegar, but we started using muriatic acid just because it's so much stronger and it does such a better job. But before you put any acid in there, make sure that you rinse it out at least 3 times. Make sure there's no bleach in there. You don't want to mix bleach and the acid. You can make other gases that are deadly. So you have to be really careful with that. So in addition to that, we do take these cells apart occasionally and we check the plates inside. They have these little screws in them, and they tend to break, and it causes the plates to shift, and so it won't operate as efficiently. So you want to get in there and swap those out and get the plates lined up and get them nice and tight again. And again, you really want to stock parts for these things. These things are really specialized. You're probably not going to be able to go down to Andrew Sherritt in a pinch and grab what you need. You will for like the SCAD 80 and stuff like that, but any of the sensors and things, the cells themselves and those little specialty screws, you should just keep that stuff stockpiled and inventoried. Okay, so just make sure you do refer to your specific manufacturer for any maintenance requirements. It's not a one shoe fits all kind of deal. Okay, and when you're doing this stuff, just remember that slow is fast. You don't want to rush through this. This is a very expensive system. So take your time and think it through. Make sure that the valves are in the right positions when you go to fire it back up. You don't want to have your discharge valve closed, obviously. This system has a fail-safe in it. It has a burst disc. So if it does over pressurize, that'll burst and then it'll just run onto the floor. But obviously, you just want to avoid that altogether. And then make sure the people around you are good to go, right? When you're mixing acid and water or when you're neutralizing it, it's one thing to have your own PP on, but just make sure that your buddy that's working with you is also ready and talk it through. And then I know it's tempting, I've done it, to rush into these types of jobs if you've done it a bunch of times because it becomes second nature. But it's really good to have the SOP out and just go over at least once with your partner because you'd be surprised little steps that you might miss and they can end up being important ones. Okay, so we're kind of switching gears. This is a case study of a wildfire that happened in California. It's called the California wildfire. And it was a big one back in 2018. They lost over 1,000 structures and they displaced a ton of people. So I'm not really interested in the damage part. As you can see, it was very devastating. It's very sad, but I'm more interested in the results. They recognized some of the shortcomings of the system, and that was a couple of things. So they had undersized generators that couldn't keep up to the process in high demand, and it ended up being boil water for 17 days for one of the counties. And you're probably thinking like that's the least of their worries, and I kind of agree, but it's just the principle of it, of having the right size backup generators to run the process no matter what. And then they had some troubles with communication and sharing public notifications, and then just extreme water system demand due to fire response and high leakage. So I think it's interesting to always remember that when you have a devastating fire like this, the services, they're getting burned up too, like the connections, and then they're open, right? And it's a huge parasitic loss on the system. So when you see like multiple fire departments going to attack these things, plus you have a bunch of services that are leaking, that is something that we have to think about. That is a huge amount of water that we're losing. And maybe it's something that we want to be in communication with the fire department for sure, but maybe it's something that we think about where we're like, hey, that part of town's gone, it's devastated, let's go isolate the mains and just shut it off because we're losing too much water and it's not useful. It's just something to think about. So what I like about it is they built relationships afterwards. So the water users, the fire department, and the people that are giving the water, the utilities, they're starting to communicate, and that's a stakeholder relationship. And they recognize that in these emergency situations, they need to have like a centralized command where emergency operations has like a center where the fire department and the water utility can communicate in real time. So we can be like, hey, we're at a threshold. We're going to start dewatering the system. You guys need to think about picking and choosing where you want to apply water. And that's just the way it is, right? Okay, so the other cool thing was that, so this, they lost a couple of pump stations in this, and they rebuilt them with cinder block and metal roofs, making them more fire resistant. And then a couple of counties actually established some interconnections with their neighboring systems for redundancy. So I thought that was really cool, and that's really why I included it. Okay, so here's the Lytton fire that happened in BC. And there's been lots of studies on it, and there's another presentation on it. If you want to know more about it, I recommend going and watching that. But there's a report out there done by FireSmart BC, and there's 3 bullets in there about the water systems. So I just wanted to highlight a couple of things that they said. So the first one is reliable domestic water supply and water delivery system must be provided and maintained for fire response. And the second one, continued water supply during power outages and increased capacity for fire protection. So there again is the power issue. They're saying that we need to be able to do our jobs and keep the water flowing no matter what, even if something as catastrophic as this. So if you wanted to put a dollar amount on these fires, here it is. Big fires, big losses. This was in 2023 Shuswap area, Bush Creek East wildfire, and the Okanagan area, McDougall Creek wildfire. Together, $720 million in insured damages. So that just really emphasizes how big and how damaging these fires really are. And again, sorry, this is a bit of an older stat. It's from 2022. But top 10 natural disasters for insurance payouts in Canada, and at the #1 spot was Fort McMurray in 2016, $4.3 billion. Again, it just shows you the magnitude of these natural disasters. Okay, this is myself and a work crew when I worked in Fort Mac. We flew into Fort McMurray, and we were on the bus to go out to camp to CNRL Horizon, and the wildfire was still on the outskirts. It hadn't breached Fort Mac yet, but it was about to. So this is just our experience, and I want to share it with you, and we'll talk a little bit more after the video. Okay, so the gentleman that took the video, his name is Dennis Rogers, and he's the guy that said, "Feel the heat." So that's the reason I included it, was when that smoke erupted, you could feel the radiant heat through the window of the bus. And again, that just really hammers home the point how much energy is behind these fires when they have a huge fuel load and they have a driving wind behind them. So that's why I included that, to kind of emphasize that point. We ended up bailing off the bus and catching rides with different people back to the airport. It was an experience, but everything worked out for us and everybody was okay. Okay, so again, we're switching gears. This is the Campbell River Water Supply. This is the intake section of the building. And I'm going to start talking a little bit about water supply and maintenance and that sort of stuff. So here's a background on the system. So Campbell River Water System, the system capacity through that plant is 1,050 liters a second max. After that, the velocities become too high against the lamps in the courts, and that's from the manufacturer. So we set aside 220 liters a second for fire protection. That's reserved, and that's in accordance with the fire underwriters' requirements. And more would be needed, obviously, in major events like that wildfire or any wildfire interface or a major catastrophic event. Sorry. So Campbell River has limited storage capacity. We only have 2 reservoirs in the main distribution zones, and then we have an additional one in the north system. They're all, that supply center supplies water to both systems, but the north system, it just has a lower service level. It's just for like our industrial zone and one street, basically. So without residential water meters in the city, we must rely closely on monitor flow data to enact water stage restrictions promptly when summer flows get to an average of 700 liters a second. So as soon as it gets to 700 liters a second on average, we enact stage 2 water restrictions, and it's actually very effective. We go down to 1 day of watering a week, and we see a significant improvement. So water metering and system storage are 2 serious considerations for future improvements for this system. And we are breaking ground in the near future, and we're putting 10 megs of storage up at that plant. So it's going to be a huge improvement for us. Okay, so let's talk about water supply. It's key to understand where your water is going. This aids us in understanding complex shutdowns, rerouting of water in emergency situations, and just the overall balancing of your PRVs and your reservoir discharges, because they're feeding into the same zones. So we want to be able to balance them and control when the reservoirs are unloading and loading. So maintaining the PRVs and the reservoirs is critical to the reliable movement of water throughout the system. Here's one of our chambers, and we just finished installing 2 new PRVs. These are clay valves, and we replumbed them and we got them online, and they're working really well for us. So zone maps. Zone maps are crucial in helping us understand where the water goes in the system. And additionally, it becomes a useful tool in manipulating pressures to change how the water flows in certain special circumstances. This is a picture of our zone map, and it has the transmission mains on it, and then it has all the PRVs and the reservoirs on it, and it shows where they're discharging into which zones. And then it has on there all the closed valves that separate the different zones. So understanding your options. So this is kind of what I'm getting at. Here's an example of using the water model knowledge to redirect water manually. That's a bit of a story, so I'll just go through it. On Thursday, 30 minutes from quitting time, we had communications fail at the Beaver Lodge Reservoir, and it was unexpected, obviously. Anyways, it turned out to be a hardware issue that couldn't be fixed right away. It was fixed the next day. But this meant that the altitude valve down at the reservoir, it couldn't see the level in the reservoir, and it was just reading its last position, which was in the off position. So the reservoir was draining uncontrollably. So we consulted our water model, and in there's some control logic, and we understood from consulting that increasing the discharge pressure from these PRVs, which sit way higher in the HDL, if we increase them by 4 psi, it would overtake the reservoir, and it would actually freeze it and not allow it to drain, and it would even fill it to a certain level, and then it would just stop. So that's what we did, because we didn't want to drain the reservoir out in an uncontrolled fashion. We want to keep that at a level where it was ready if we needed it for, say, a fire response or something like that. So this is that reservoir, and I'll just briefly go over the maintenance of that from my point of view. And so along with the PRVs and the reservoirs, the reservoirs need attention. So this was a couple months ago. We drained and isolated it. Operators entered, we gave it a thorough scrub, a power wash, and then we gave it a good bleach. And then after that, we gave it an inspection for tears in the lining, and then just an overall look at the structural components, those pillars, the drains and the fill line, all that kind of stuff. And then we take pictures so it's documented so we can compare it for the next time that we go in there. And then after that, we undo the lockout, and because of course we had to lock this out first. Then we fill it up, we test the quality of the water, and then if it comes back where it's all good, then we put it back online. So this is a 3-year cycle. We're going in here and cleaning this, but a part of the package is the altitude valve that is actually located at the reservoir. And we want to make sure that that's getting looked at way more often than 3 years. That should be a part of the PRV preventative maintenance package. So we want to make sure that the solenoids and the diaphragms and the speed controls on these valves are being looked after to make sure that they're running reliably. Okay, so here's a little bit more on actual PRV maintenance. To the left, the big picture. This is from the Willow PRV. It's a 10-inch valve downtown. And so we do a biannual PM. PM means preventive maintenance. And we pull the basic strainers out. We clean them off. This one's disgusting. And we reinstall it. We take the diaphragm. We do a leak test on it. And then we check the pilot system over, which includes the speed controls, and it has its own little screen in there, and we make sure we clean that out as well. This PRV is one of our main ones. It's actively on duty. So the biannual inspections, that means twice a year. Those are for more like the underground ones that don't see a lot of action. This one will probably get 3 or even 4 biannual inspections done to it. So maybe it's actually like a quarterly inspection for this specific valve, just because it sees so much action. And then outside of that, we have a 5-year maintenance plan, and we remove the seats, the rubbers from the valve, replace them. And then we also, in the bottom right picture, we take the diaphragms off and we install new diaphragms, as well as the pilot system diaphragm. Because you just want to make sure that this stuff's all running good, because if they're not, you can cause damage for one, but also if there's a big fire event, you want this thing to come on as it should and then turn off when the event is over. Okay, so another part of that biannual inspection is these ports. The valves have upstream, downstream, and head ports, and the upstream port takes high pressure water and it puts it through onto the head, the cover of the valve, and that's how the valve is regulating, and it runs through a pilot system. So if you don't make sure that these are cleared out when you do your inspections, what happens is that carbuncles, it can build up in the port, and then you lose your supply to the head of the valve. Basically, you lose control of the valve. So this was a valve that was forgotten about and neglected for about 4 years, and we went and attended it, and we found that the upstream port was actually plugged, and the valve was no longer regulating. So it was set at 100 pounds. We found it discharging 140 pounds, and luckily it didn't break anything. So we adopted it, we replumbed it, and we got it running, and we got it set properly. So it's good to go. So that just highlights the importance of your PM schedules. Also, when we install plumbing on the pilot system and on these ports, we replumb them and we put T's in. So you can go there, isolate it, and then you can just take the plug out of the T, and then you can rod the port with a brush or a screwdriver instead of having to take the valves off and all the plumbing. It just makes it way more streamlined. It's really nice. Okay, so this was a fire that happened about 1.5 years ago. As you can see, there's one engine, they're blitzing it. They have a deck gun on top, a master stream, and then in the foreground, there's a fireman with a 2.5-inch line, and then way in the back, you can see another stream. It looks like a 1.75-inch line, probably a pre-connect, and they're blitzing this fire and they're preventing it from spreading. They're doing a good job. So we can trend all this stuff on SCADA if we understand where the water's flowing to. So that Beaver Reservoir, if you look at the 11 o'clock mark, that's where the firefighters are pulling water just before 11. And we know this because we know where the water goes for each zone. So we know what address they're at, and we know what corresponding zone they're in, and then we know what PRVs and what reservoirs are feeding that zone. And then again here, this is the Rockland Alder PRV, which was pictured earlier in the slides. Again, if you look just before 11, that's them working, and they're pulling water to the fire from this valve and from that reservoir. So we can track that data, and they're roughly using between 40 and 50 liters a second. So you can imagine that's just one house fire with one engine. If we had some kind of interface situation where it was the whole fire department plus mutual aid, that's a ton of water, right? So we want to have that command structure in place, and we want to be talking with one another. We can tell them, hey, you're getting to that threshold. This is how much water's left. You guys might need to start picking and choosing and adjusting your tactics. Okay, so here's the Willow PRV, and it feeds the downtown. And it's kind of a neat setup. There's some new programming, and there's a solenoid actuated pilot control system. So there's a regular conventional pilot system, and then there's also this pilot system that's controlled from SCADA using a solenoid. So why that's important? There's another reservoir called Evergreen Reservoir, and it sits in the highest zone in town. It's way at the top. And this valve sits way at the bottom, but this valve has 200 PSI behind it. So the people that designed the water model, they recognized that both reservoirs, when they're loading from their altitude valves, were pulling off the same trunk main, and it was dropping the pressure in the south end of town. So they were able to design these valves to have a solenoid click on at predetermined set points. And what it does is it increases the pressure by 18 pounds, and then it pushes water up into the zone where the Evergreen Reservoir is, and it fills it from the downtown, utilizing that high pressure. And that's why I mentioned in the first, I think it was the first or second slide, that backhoe picture, those are the weak spots that are being found by this new control logic. When we're turning it on by 18 pounds, all the weak spots in the system are coming out and rearing their heads. Okay, so with this in mind, that didn't cause this. That's not what I'm getting at. What happened here, this is a private hydrant that was tucked in behind a warehouse down by the ocean, and it was sub-zero conditions, and somebody left this hydrant fully charged, and it popped. And so what happened was, over a course of several days, we approximate 47 million liters were lost through this thing. And what happened was that solenoid, let's go to the next slide. That solenoid clicked on about 9 o'clock. So you can see at 11 o'clock, it broke, and then you see the discharge go way up, this red line. And then the solenoid clicked on, and it pushed out what is that, like 100, almost 120 liters a second. But the parasitic loss from that hydrant was just too much, that the reservoir kept draining. So we came in and we noticed the reservoir was draining, but the valve was pumping out almost 120 liters a second. We're scratching our heads, like, well, there has to be a leak, right? The water is supposed to be going into the reservoir, but it's not. And so we searched the downtown because we understood that this water's in this zone and it's disappearing. It's not making its way into the top end of town. So we eventually had to switch over to the old way of filling the reservoir, so we could stop it from draining. We could have just isolated it. We realized that, but for the person on call, it's just easier if we switched over to the altitude valve and started loading that way. And you can see the blue line here, that's representing the level in the reservoir. So we're able to start filling it again and start utilizing our fill times and all that good stuff. So we did find the leak, shut it down, and then we were able to go back to our way of filling from the solenoid actuated valves downtown. So again, that's just understanding your zones and understanding the water model and which valves do what and where they feed. And it just helps us a lot with troubleshooting. Okay, so this is something I just threw on here because I thought it was interesting. We have newly acquired listening devices or pressure detection for leak detection. So these hydrants, this is like the third party that does this, a company, and we take off the old hardware and we put this new hardware on and we put it throughout different zones, and we're monitoring some of the data and characteristics that these things are picking up. I won't say too much more about it because I don't know enough about it, but I just thought it was an interesting piece of kit, piece of technology that's out there. If anyone else is using it or has something to say about it, I'd love to hear about it in the conversation period after. Okay, here's the Terminator. The digital world of water and emerging threats. So automation is advancing, technology is great, so are the threats. AI is still largely unregulated, as we all know, and tech companies and state actors, they're kind of in the next arm race to create machine learning. And I feel like all of us are stuck in the middle. So this is from cyber.gc.ca, the federal government. And this is what they have to say about it. So state-sponsored actors are targeting critical infrastructure. State-sponsored actors target critical infrastructure to collect information through espionage, to pre-position in case of future hostilities, and as a form of power projection and intimidation. It's real James Bond type stuff, and I find it very fascinating and kind of troublesome as well. Okay, so the cases are rising. This is from the same site, federal government. Cyber criminals target critical infrastructure. The Cyber Center is aware of over 100 cases of cyber threat activity targeting Canadian municipalities since the beginning of 2020. So keywords, municipalities, that's us, right? And we're the ones that are running these critical infrastructures and utilities. So it's something that should be on our radar at the very least. So this is a quote from a letter from the Environmental Protection Agency Administrator Michael Regan, and at the time, the last administration, National Security Advisor Jake Sullivan. This is American. So the quote is, drinking water and wastewater systems are an attractive target for cyber attacks because they are a lifeline. Critical infrastructure sector often lacks the resources and technical capacity to adopt rigorous cybersecurity practices. Reagan and Sullivan wrote in a March 18th letter to all 50 US senators, or governors, sorry. So again, even at the highest level of the American government, they're talking about it. And I actually listened to something very interesting lately from an Air Force brigadier from the Americans. He was talking about some of their SCADA systems in the power supply side of things, and they know of viruses and things that are already embedded in their power supply systems that they can't get rid of. So it's on their radar, and they're talking about it a lot. And I think that it's interesting. It should be a part of our conversations as well. Okay, solutions for the institutions. This is a cheesy title, but I heard it a long time ago at fire school, and it stuck in my head, and now it's stuck in your head, hopefully. Proper preparation prevents poor performance, and it is true. So how do we manage risk? Starting with the basics of developing an emergency response plan. We want to identify risks. We want to try to mitigate the risk. Emergency contact list, who's on it and who's qualified really for what positions in which situations. So I'm talking about like SCADA, power issues, pump issues, that kind of stuff. Standard operating procedures, for example, mercury cleanup, DOSI pump failure, pump faults, and SCADA communications. I just kind of repeated myself. Use the experts. We have the fire service, so we can have them inspect your sites for interface wildfire threat. Have a pre-plan in place so that critical roles are predetermined and rehearsed. Invest in IT security because it's going to become more and more critical. And then everyone who needs to know the plan, anyone who's in the plan should know that they're in the plan. Don't just write someone's name down that you would think would be a good fit for a role and then not tell them about it. That's crazy stuff. So make sure that they know, and make sure they know what the expectations are. And then revisit, revise. Okay, so we're doing what we can, right? Solutions aren't always perfect. I know that. We attempt to mitigate problems with the tools at our disposal. That's all we can ask for. So we're making the effort and the noise for the sake of due diligence. During the summer months, we put a sprinkler up on the roof of our water supply center. This is the Fireboss Mini, and it's just one of those things that we do in an effort to protect the facility in case there ever was a wildfire that rolled through here. Okay, so another thing I just want to talk about quickly is regular inspections. Inspections lead to identifying issues before they become problems, ideally. So planned work is better than reactive chaos. When it's an option, we choose the control version of system improvements. We don't just let things blow up. We try to maintain them and we try to improve them. I was in a PRB chamber doing some maintenance not that long ago, and I noticed the deflection in this bypass line, and this is a high pressure line. So this is unacceptable, and it's a problem, and we're gonna take it offline, and we're gonna get rid of it. We're gonna put some blind flanges and just take it out completely. So this is the water supply center, and that's the tree line. So that's why we have the sprinkler on the roof. If there ever was a fire and there's embers and things like that, we just want to keep the roof wet. This is our main power supply, that bottom right picture. That's where our hydropower comes in. And then on the back side of that, we have our emergency generator. And then in front of that is the diesel tank. And it's actually the closest to the tree line. So we have some hoses and some nozzles that just sit on that again during the hot months, and then we can just turn the hydrant on, open a valve, and then that stuff's getting cooled down with water. Here's the Fireboss Mini again, and then here's some hoses that we just brought out, and we're just making sure that there's no leaks in the hoses, and we're just trying out the system, making sure that we have ample pressure and all that good stuff. Okay, so be resilient, engage with stakeholders, have multiple sources and routes for material, build in redundancies for critical systems, train and qualify your people, Develop, revise, and practice emergency response procedures. Be reliable and keep the water safe and keep it flowing. Here are some of the available resources out there that you guys can use if you're interested. The EPA actually find is quite useful. It's the Environmental Protection Agency. That's our American counterparts. Fire Smart BC, the wildfire, the provincial BC wildfire website. They have some good stuff. Of course, the EOCP and the BC WWA. Your local fire departments, should definitely talk to them. The Water Distribution Operators Facebook page is hilarious. If you guys are operators, definitely go check that out. It's North American wide, and there's just all sorts of funny stuff on there, and good stuff too. You get to see what other people are up to outside of our jurisdictions, and yeah, some of it's pretty comical, and there's some lessons to be had. And then, of course, the BC Small Water Systems Online Help Center. That's this platform. There's lots of good stuff. This is just a picture of our biggest transmission main, our 30-inch. On April 1st, April Fool's one day, a contractor put an excavator tube through it, and me and another buddy, we went there to assess it, and we didn't know that's what they had hit. So we called our supervisor, and the hardest part of this whole day was trying to convince him that this actually happened. It was great. It was terrible at the same time. It was a big day. Okay, this is an honorable mention to the City of Vancouver for their fire protection redundancy system. It's called the Dedicated Fire Protection System, and it's quite impressive. I think it's like one of 3 in North America, I believe. I won't talk too much about it, but there's a gentleman named Brendan Kurgan, and he does a piece on it in the Vancouver's Awesome News page, and it's worth checking out. It's really neat. Every time I'm in Vancouver and I see one of these blue hydrants, I'm like, oh, this is great. It was so cool. And I'm usually with my wife, and then, yeah, check this out. She's like, please stop talking about this. It's not that cool. Anyways, I just want to give a special thanks to all the operators and the staff in the Campbell River Water Department for their shared experiences and lessons. Everybody's really good at sharing things that didn't go right, things that did go right. We have a pretty good group there, and everyone is pretty good at sharing, so it's really good. And then just an extra thanks to the Chief Operator of Facilities, that's Ed Travenot, for sharing his expertise and his professional mentorship. All the redundancies and all the spare parts in the cataloging, all that stuff, and all the PRV maintenance, he taught us all that, and that's really his bread and butter. He leads us through that. So thanks a lot, Ed. And that's pretty much it. That's the conclusion of this. I have my email up here. If you guys have any questions or discussions outside of this, feel free to email me, and I'll pass this back to Satwinder. Thank you, guys.
Thank you, Nick. That was perfectly timed, and a great
Good.
presentation. We get to hear about the application of resilience and recovery as it's practiced by a system. So what an honor to have you present on that. So we'll open the questions to our attendees. If you wouldn't mind noting them into the chat, I will read them to Nick, and then Nick will answer back. So, Nick, we have our first question, and it's from Shaki. What shelf life does the salt have before it's mixed into hypochlorite solution?
So it gets added daily into a brine tank, and we try to keep it pretty full above the water level. And it goes through, like I was saying, we go through about a pallet a week. Is that kind of what the question was?
Yeah. So, like, does the sodium, the brine, does it have a shelf life?
Not that I'm aware of.
Okay.
Not that's been brought to my attention, but I'll note that. It's a good question.
Okay.
But as far as I know, it doesn't.
Yeah. So we have a self-generating sodium hypochlorite system as well. So the salt is always topped off, and then we create a brine solution that's fed into the chlorinator. So yeah, to the Chlorotech machine. So so not that I know it has it doesn't have a shelf life. So okay.
Not that I'm aware of.
Oh, he's saying, oh, I'm asking how long we can keep the salt.
Oh, like keep pallets of it? I've never seen a expiry date on it, so I think that it should be okay. It just comes in these bags, and I don't think it degrades. Not like hypochlorite would.
Yeah. Okay. Next, would I be able to get a copy of the PowerPoint presentation? Yes. We post all our webinars, slides, and the recording of the webinars on the website. So it should be on there in next few days. So if you want to look at the PowerPoint again. Okay. Okay, sorry. Our next question is from Kalpana. So many of these treatment facility buildings are not fire resistant. Are there any guidelines for new buildings to use fire retardant building materials?
Wow, that's a great question. I honestly don't know the answer to that. Um, I would have to look at the regulations, but I don't have a concrete answer for you. This plant was built in 2017. And as you can see, they used wood on some of the outside exteriors. So a lot of it is cement, but there's also quite a bit of wood attached to it. So I would say I would lean towards no, but I don't have a for sure answer as far as the regulations go.
The next one is not a question, but Ashley just wanted everyone to know that you can download up-to-date emergency response guidebook app for free on Androids and Apple stores. So
Awesome, very cool.
okay. Next one is Andrew Hunt. He's just complimenting you on a great presentation, Nick. So
thanks very much. I appreciate that.
Ethan asks, how often are you checking the high pressure points on your altitude valves and PCVs?
So the altitude valves we can monitor from SCADA. So we see that data every day in real time. But some of the bigger valves, like the Willow PRV and the Brooklyn PRV that I mentioned, we go to those every single week because they see so much flow that we switch them or we take them offline and we clean the pilot system to make sure that there's no plugs because it has a little screen in there and they get very dirty, especially this time of year with the high flows. So we go there at least weekly, but we review the data for high pressure stuff through SCADA every day. Yeah, we see that.
This was really proactive of Campbell River to do this because most utilities are thinking about it, you know, because these emergencies we experiences are becoming a repeat every season. So what took you to, what kind of conditions led you guys to think this way, to make sure that you're building and developing plans for resiliency and so on? Nick?
So I have to give a lot of credit to our chief operator, Ed Shravanat is his name, facilities. And he comes from a background of pipe fitting in the pulp mill industry for a lot of years. So preventative maintenance is what is the driving the driving factor to success in pulp mills and anything that is a process. So he brought a lot of that over, I believe, from his past career. And when he came into this industry, he implemented a lot of the preventative maintenance and then the redundancies behind it. He's he's a very good operator and he's a very good leader. And he has a lot of great ideas, and he has a lot of stuff that he brings to the table from his past experiences. As far as the fire stuff up at the plant, that was some discussion between operators, and we kind of just felt like there should be something in place. We can't just rely on the fire department, because when these events roll through, it becomes very chaotic, and it's too late to come up with a plan in the chaos. So we wanted to make sure that we had these things in place, and it's easy to do, right? Buy some fire hose and some nozzles, and there you go. You kind of have at least sort of a plan in place to control heat as it's applied from the radiance of fire. We can cool the building with our hoses, and then also we can just open a valve and turn that sprinkler on. It's as easy as that. It's just something you can have in place. So, yeah.
Was there a cost? Obviously, there was a cost factor. Like, you had your usual preventative maintenance, and then you went to build this resilient and reliant systems. So there must have been a cost factor to add that bit on. So,
just for the fire stuff, you mean?
Fire staff, redundancies, and so on.
Yeah. So the fire, yeah, and you have to be. I don't have a budget. The facilities has a budget, distribution has a budget, and then the water department as a whole has a budget. And as you know, everybody's all these budgets are broken down into different codes, whether it's safety, plant, or just regular maintenance budgets. So I think that the people that are at the top that want to make things happen, they have to be very creative in how they allocate resources and money. And maybe that just means you borrow from one budget and put it into another one, and you make it work. And it's easier to do, I think, if you have a business case. That's a very expensive plant, and if we don't have the plant running, that means there's no fire protection. And even from just an insurance outlook, that's really unacceptable. So it's a pretty easy sell to say, hey, we want to build a little bit of a redundancy with fire protection. We have a full-time fire department, but who's to say in a crazy situation that they're not preoccupied? So we just want to buy some hoses and some sprinklers, and we want to implement that. It's a fairly easy business case to make. The stuff doesn't cost a ton of money, but yeah, you're right. It does have a dollar sign beside it.
We have a question from Will. What incentives conservation if use don't have metered accounts? Okay, what incentives can you use to make sure that you have users don't have metered accounts?
The meter thing is something we talk about quite a bit just as operators. The incentive to get meters actually is that if we can control how much water people are using, because every year our city is growing, we're building quite a bit here, and so we're adding services, right? And there's a lot more water usage. This puts strain on the system. So at some point, they're going to have to build the system out and add capacity. If you look back in the slides, you'll see that there's a UV train there that's not utilized. There's no spool, no pipe. It's not hooked up yet. That's for future build out. So if we continue down a path where we build lots of extra infrastructure and add services, there's a potential that we'll have to trigger a build out much sooner because of the usage. So one of the arguments would be if we had a universal metering program, perhaps that would slow that process down. Is that kind of what you meant, or did I miss the mark?
Uh, I think you answered the question.
Okay.
They'll ask a follow-up if we didn't cover it. Chris and Lynn, it's not a question, but they're saying that hempcrete can be used for buildings in the future to
Mhm.
make them fire resistant, I gather.
Sure. Yeah. Cool.
Uh, Question for Mike. During winter months, when you get a leak detected and under snow and ice, how do you know where the possible leak is located? Similar to the fire hydrant, but underground.
Yeah. So that's a good question. Because we don't have meters, we do a lot of listening. So if we have a leak, we will, if it's under snow especially, yeah, it's very hard. What we have to do is locate the curb stops and listen to them. And that's kind of the best we can do. We shut them off, and if we can hear a leak, if we hear water running with the curb stop shut, that means that the water is on the back side of the valve, right? You can hear it escaping. And then we also have listeners. So they look like this through our headphones, and then you have a listening device, and you take it out and you put it on the road, and then you can kind of figure out in a general area where that leak is. Um, yeah, it's pretty rudimentary, but that's how we do it.
Yeah. Well, you did invest in the new leak detection equipment and so
Yes.
on as well too. So yeah. Okay.
Yeah, they are using that.
Next question is from Barnett. Do you have a confined space assessment manual as required by WorkSafe BC?
Absolutely. Yeah, we do. And again, the chief operator, Ed, he had a consultant work with us, and they developed kind of a lockout plan for anything that's 3-inch or bigger in a confined space. Excuse me. You have to consider a lockout for it. And so it's based on the type of valves that are in the ground and how much leak by is going through those valves. If they're older valves, you can't get them quite seated. You're allowed a certain amount of leakage. I don't have those numbers off the top of my head, but if you give me your email, I could find that information out. But yeah, we definitely have a confined space program. So we're testing the air before we go in. We're testing it while we're in there, like constantly. The person who's in there is wearing a monitor. The person outside has a monitor as well, so we have redundancy there. And then we have fall restraint as we're going in and out of the hole. So if you were to fall, you wouldn't fall 10 feet into a hole as you're coming and going. So yeah, absolutely.
Chris and Lynn asked, please, a source or more info on high flow leak alarms. A huge quarterly bill is a bit late for finding a lawn leak.
Oh, okay. So sorry. So this is out of like a commercial meter.
It's just saying high flow leak alarms. Are there high flow leak alarms in your
Oh,
system?
I see.
Yeah.
No. So I see what you're saying. Yeah. So we monitor all of our flows from SCADA, and like yeah, okay. Because what I was saying in the presentation about um, that fire hydrant exploding. Okay, so no, we don't have alarms necessarily. Um, we do. Some of the PRVs have, if they're attached to SCADA, have a high pressure alarm. Um, that's only one of them. But as far as high flow alarms, no, actually. We look at the data every single day, and we just look at the trending, and that's where we pick up on that kind of stuff. So as far as alarms, I don't think so. Not in that case. We have a lot of alarms for other things, so.
Yeah. So you mostly monitor it through your zones and see what's happening and all that kind of stuff. So you would be able to pinpoint that way,
Yes.
right? Through, yeah. Through
Yes.
Zoom.
Yeah. Through SCADA mostly.
Okay. My question was, did you install any extra monitoring equipment once that BC Hydro dam construction started? Did you need to install extra monitoring equipment at your source?
We talked about it. We have a raft that we don't really utilize out on the far side of the lake, but we decided not to because we weren't sure if we could get the right instrument to capture how small of a discrepancy of turbidity it would be, because we have really low turbidity as it is. So we did bat around the idea. I know that BC Hydro is doing monitoring, and they have a third-party company, like an environmental company that goes out and does testing for them. And then we're just carrying on with our regular sampling regime, and then our real-time sampling from our raw water board. Yeah.
Did you increase your monitoring because of your resilience and reliable system planning? Did you increase, your process monitoring and so on?
Nope, that stuff has been in place. Actually, when they took the gas out of the system, some of the planners and this is what I'm talking about with the stakeholder relationships, that were not necessarily a part of the water department. They were, whether there's a senior management, engineers, those types of people, which have an important role to play, but they don't really understand the system as far as daily operations go. When we got rid of the chlorine gas, that building turned into an instrumentation center. So not me, Ed Trevenant, he added a bunch of monitoring, because we have the mains. The mains are right outside that building. So we have all the chlorine monitoring, the turbidity and conductivity and pH and temperature monitored at that building, because between that building and the water supply center, the water is coming down there for about 3 kilometers? No, 3 hours of contact time, and before it hits our first customer. So that building is actually the best information we have before it gets to our first customer. It's even better than the information at the plant.
Okay, excellent. Question from Christopher. With all these cyber attacks and risks going on, do you guys allow for remote SCADA access from your phones or off-site locations?
Yeah, it's a good question. We do. We still have, there's a couple things you have to do to log into it. When you're remotely active, trying to actively remotely log in, there's authenticator apps that work with it. And so it's a layer of security. But yeah, we do, not so much on our phones, because it's just so hard to blow up the screen and touch buttons, but certainly from like an iPad, it's usable and useful. So yes, and we have an IT department, so we're lucky. Our city and our department is big enough where we actually have an IT department, and they actually know how all this stuff works and know what they're talking about, and they can implement the proper security measures and keep an eye on it for us. So yes.
Okay. Kalpana is sharing a resource. She says that Andrew Welton has done a great deal of work on the impacts of wildfire on distribution system, and she's given a YouTube link for that.
Great.
In the chat.
Hey,
yeah.
excellent. Love it. What was the last name? Welton?
Yeah, Andrew Welton, Whelton.
Great. Great, thank you.
Pavel is asking, do you have any ways of tracking non-revenue water and identify leaks?
That's a good question. Not really outside of um, averages. And if we see something that is using the data, the trending data in SCADA, it's very useful. Um, and that's kind of the best we can do at this point. We do have meters for commercial sites. All the commercial sites have meters, and all of our big PRVs have like mag meters attached to them. So we have that. But as far as having, say, if the best case scenario would be having all the PRVs metered, and then we know exactly how much water is going into each zone from every valve. And then if every customer had a meter as well, we would know how much of that water going into that zone is going to the customers. And then the difference would be water loss, would be leaks between the two meters. So we're not there yet. So my answer, I guess, is no, except through SCADA trending.
Taiwo asks, do you think it is easier and budget friendly for old systems to upgrade or new system included in the planning?
That's a good question. Not sure. I'm not an engineer and I don't have a lot of project management experience, but I think that it's really difficult. To put that onto developers. It does happen where you're like, okay, if you're doing this, you have to do this as well. So there is some of that, like upgrades that's included in new development packages. But as far as doing like, a kilometer of water main and sewer main, I don't know. I mean, it's a lot of money, and it's getting to be harder because there's so many more permitting requirements. Now in our town, we have to have archaeology permits in a lot of areas, and that's a provincial mandate. So again, we're trying to work around that and find ways to streamline these processes without adding a huge amount of cost to it. So there's a lot of challenges around it, and that's why I mentioned I think that all the communities across the country are kind of in the same boat. We have a lot of old stuff in the ground, and it's fine to put new stuff in for new developments, but we have to deal with the old stuff. We can't just leave it there forever. So, yeah, and that takes a lot of money, and we'll see how that pans out.
Christopher is sharing, if you want to have a good idea on what a metering program looks like, the city of Fort St. John has an excellent meter program and it's working very well.
Okay, thank you. Appreciate that.
Yeah. Heather asks, what type of communication and or power supply required for hydrant leak detectors? Are they remote, and do you know how accurate they would be?
Yeah, they are remotes. This technology that we have, the company has a battery pack attached to it, and then it communicates back to them, to their site, and then they upload the data, and we have access to it, so we can go online and you can look at it. As far as accuracy, I couldn't really tell you, to be honest. I think it's probably pretty good, but I couldn't say for sure within PSI or whatever it is. But they do have a battery pack, so you just have to switch the battery out once in a while, and it actually communicates that to the site. It says, we're low on battery, and then you just go there and switch it out.
Ethan asks, when testing backup systems, how long are you testing? We found out recently our place died in 4 hours and lost all communications. 4+ hours seemed like a long time to test backups.
Backup as in power, or as in like your bleach system or something like that?
I think it's kind of saying all of them. Power. He's
Okay.
yeah. He did a follow-up.
Power. So we're lucky here. We have a maintenance crew. We have 2 electricians, and they turn on our generator and they run the plant off it. And they don't do it for very, very long. But it is designed, it's over designed. It puts out, I think, what is it? I have it here. Sorry, I have it written down. I don't remember, but we're using like a fraction of what it's capable of using on our if you're to compare it to our hydropower, we're using a fraction of what that thing's able to put out. So, and they put that there with the idea of building out as well, right? So, yeah, if you guys ran it for 4 hours, I think it ran out of fuel, or is that what you mean? If you ran out of fuel, I mean, that's kind of an easy thing. You could have a tidy tank rolling back and forth and filling it back up and just keeping it topped up, and then it would be able to run for as long as you needed to, I guess. But as far as like the bleach and stuff, it depends on the flows. Right now we have like a 16-hour backup when we have 2 barrels on site. So we're gonna try and keep a double that on site in case we have a more lengthy repair. But at least it's something, right? We don't want to have a situation where we got to do repair and then we have to turn off our treatment. It's just not acceptable.
Yeah. And how long does your 12% supply last as a backup?
Yeah, if you have 2 barrels, it lasts you about 16 hours with these kind of flows.
Okay, so your self-generated is 16 hours, and so is your backup 16 hours as well too?
Just the backup. So if you had, like, if you're running at 12%, yeah. So that's with 2 barrels.
Okay.
But like I was saying, we have 4 barrels normally, or we're going to.
Okay, I gotcha.
Yeah.
Okay, I think that's it for our questions. Nick, what an amazing presentation, and thank you so much. We will be posting the slides within the next couple of days. If you have any more questions for Nick, you're welcome to email him directly. He shared his email with you, or you can email to us at the Online Help Center, and we'll make sure that we forward those questions to him and get them answered. Our next webinar won't be till September, so it's coming up in September 23, so we'll take a break for the summer. And our next webinar the topic is operations and maintenance of ultrafiltration membrane systems. I hope you will register for that, and we will see you in September. Thank you everyone for attending, and thank you again, Nick.
Thanks, Satwinder. It's my pleasure.
I hope you will come back and do another presentation for us in the future.
Yeah, maybe. We'll see. Sorry, I just found that we used about 400 kilowatts in the peak demand, and our generator is good for 1 megawatt. That's what I have in my notes. So I hope that helps answer your question. But yeah, thanks very much for having me, Satwinder, and everybody for tuning in today. Thank you.
Thank you. Take care. Bye-bye.
You too.